Today we'll review writing linear equations, and then we'll look at writing linear equations of lines that are parallel and perpendicular. Our first example is a review of writing equations of lines. We need to find the slope-intercept form of a line that has a slope of -1/2 and goes through the point -4, 1. We know that -1/2 is our m value, and that -4 is our x1 value, and 1 is our y1 value. That is for the equation y minus y1 is equal to m times x minus x1. Now all we have to do is plug in the information we know. Y minus 1 is equal to -1/2 times x minus a -4, which is plus 4. Remember, the minus and negative changes to addition. Our next step is to distribute. So we have y minus 1 equals -1/2 x. -1/2 times 4 is a -2. Now we need to add 1 to each side. So our equation is y equals -1/2 x minus 1. That should have been a review from yesterday. Our next review example gives us 2 points, and we need to find the equation of the line that passes through these 2 points in slope-intercept form. First thing we have to do is we have to find the slope. We need to designate our x1 and y1 values and our x2 and y2 values. Remember, to find the slope, we'll do y2 minus y1 over x2 minus x1. Now we can just plug those values in. Y2 is 2 minus y1, which is 6, over my x2 value, which is -3, minus my x1 value, which is +3. 2 minus 6 is -4. -3 minus 3 is a -6. So I have -4 over -6. That gives me 2 over 3 if I reduce it, because the negative over negative changes it to positive, and then 4 over 6 reduces to 2/3. My next step is to fill in my point-slope formula. Again, that point-slope formula is y minus y1 equals m times x minus x1. So I have y minus 6 is equal to 2/3 times x minus 3. The next thing we do is distribute. Y minus 6 is equal to 2/3 x minus 2, because 2 over 3 times 3 over 1 is equal to 6 over 3, which is the same as 2. That's where that 2 value came from. And then you have a positive times a negative, and that gives us a negative. Alright, the next step is to add 6 to each side. So we have y equals 2/3 x plus 4. And that is our equation. The next example that we have says use the graph below to find the slope of each line. The reason we're using slopes is because perpendicular and parallel lines are dependent upon slopes. So let's find the slope of line A. Line A is this line right here. What we need to do is pick 2 points and count rise over run. I'm going to pick this point and this point. It goes up 1 and over 2. So our slope is 1/2. Now I need to find line B. I'm asked to find line B, which is right here. Goes up 1 and over 2. So again, my slope is 1/2, 1 over 2. For line C, which is this line right here, I count up 1, 2, and over 1. So it's 2 over 1, or we could write it just as 2. And then I need to find the slope of line D. If I count rise over run, it goes up 2 and back 1. So it's 2 over -1, which is the same thing as -2. Then if you notice the questions at the bottom, it says, what can you conclude about lines that are parallel? A and B are the two lines that are parallel. What do you notice about the slopes? Both of the slopes are the same. Lines that are parallel have the same slope. Then it's asked, what can you conclude about lines that are perpendicular? Remember, perpendicular lines form a 90-degree angle. And from way back when, you know that 90-degree angles are signified by this box where two lines intersect. So you have line A and line D that are perpendicular. Line A has a slope of 1/2, and line D has a slope of -2, or 2 over -1. If you noticed, A and D are almost the same fractions, except for they're flipped from one another, and D is negative where A is positive. We call these negative reciprocals. So perpendicular lines have negative reciprocal slopes. Negative reciprocal is just a fancy way of saying flipped and the signs have changed. Our next example is on the back of the page. You're given slopes and you're asked to find the parallel slopes and the perpendicular slopes. Remember, parallel slopes are the same, where perpendicular are the negative reciprocals. So if you're given a slope of 2/3, your parallel slope will be 2/3 as well. Your perpendicular slope is where we take the negative reciprocal. So you flip the fraction, which would be 3 over 2, and then you change the sign. It is positive from the original slope, so now we'll make it negative. Then we're given a slope of -4. The parallel slope is the same, so it is -4. Our perpendicular slope, again remember, is the negative reciprocal. But the problem is we have a whole number here. It's not in a fraction. To make a whole number a fraction, we always put it over 1. So we have -4 over 1 as our original slope. To get the perpendicular slope, we flip that fraction. It's 1 over 4, and it was negative, so now it's positive. For a given slope of -1/4, the parallel slope is -1/4 as well. The perpendicular slope is a +4. Parallel slope for a given slope of 2 is 2. And the perpendicular slope for a given slope of 2 is negative 1/2. If your given slope is 0, your parallel slope will be 0 as well. Those would both be horizontal lines. Your perpendicular slope would be a vertical line. And we know that vertical lines have a slope that is undefined. Next, we are given equations, and we are to determine if those equations are lines that are parallel, perpendicular, or neither. If you recall, we know that slope-intercept form is given in y equals mx plus b. That's a plus sign. I'll erase it. We know in this equation, y equals mx plus b, that our m value is the slope. So we need to determine, looking at number 1, if y equals negative 1/2 x plus 4 and y equals 2x minus 8 are perpendicular, parallel, or neither. First, we need to identify their slopes. In the first equation, negative 1/2 is the slope. In the second equation, 2 is our slope. Remember, 2 is a whole number, so it can be written as 2 over 1. If you look, the fractions are flipped and the signs are different. So this means that these two lines are perpendicular. Let's look at the next two lines. Y equals 3x plus 7 and y equals negative 3x plus 2. In the first equation, 3 is our slope. In the second equation, negative 3 is our slope. Those aren't flipped. The only thing that's different between those two values is that one is positive and one is negative. So for these two lines, they are neither parallel nor are they perpendicular. And lastly, we have two equations. One is y equals x divided by 7 minus 6, and one is y equals 1/7 x. X divided by 7 is the same thing as saying y equals 1/7 x minus 6. So our slope is 1 over 7. Our slope in the second equation is 1 over 7. If our slopes are the same, that means lines are parallel. Write the equation in slope-intercept form of a line that passes through the given point and is parallel to the graph of the given equation. Our point is 2, 9, so I'm going to go ahead and signify those as x1, y1, and our equation is y equals 3/4 x minus 5. We are asked to find a line that is parallel to this one. Recall that if lines are parallel, we need the same slopes. So our slope in this equation is 3/4. We don't need any other information from that equation. So now I'm going to plug it in to my point slope formula. Y minus 9 is equal to my slope, which is 3/4, times x minus 2. Next step is to distribute the 3/4. So y minus 9 equals 3/4 x minus 6/4. But wait, we can reduce 6/4 to be 3/2. Our next step is to add 9 to each side. Oh wait, we're adding a whole number and a fraction. We can't do that. We need to change this 9 to make it into a fraction. with a base of 2. We know that we can take any whole number and put it over 1 and make a fraction. But I need my fraction to have a denominator of 2. What did I multiply 1 by to get to 2? That's easy. We multiplied by 2. So 9 times 2 is 18. So I'm actually going to add 18 halves to this side. We're adding 9, but it's in a different way. So our equation is y equals 3/4 x plus 15 halves, because we added -3 halves plus 18 halves. In our last example, it says write the equation in slope-intercept form of the line that passes through the given point and is perpendicular to the graph of the given equation. Our point is 6, -13. I'm going to go ahead and denote those as x1, y1. And our equation is y equals 2/9 x minus 5. The information we need to know is the slope, which is 2/9. We want that line to be perpendicular, so what do we do with the slope? We have to change the slope to be its negative reciprocal. So we flip the fraction and change the sign. So our slope will be -9/2. Now we use the point slope formula and plug it in. Y minus a -13, so y plus 13, is equal to -9/2 times x minus 6. We have to distribute. Y plus 13 is equal to -9/2 x, and then we have to take 9/2 and multiply by -6/1. -9 times -6 is a positive 54. 2 times 1 is 2. 54 divided by 2 is a positive 27. Now I have to subtract 13 from each side. And my equation is y equals -9/2 x plus 14. Now you need to work on your assignment. There are about 18 questions of writing linear equations and then writing the equations of lines that are parallel and perpendicular.